Ayan. So, for the first words actually, what is this? Ano kaya yung sinasabi ng jumbled letters na yan? Again, our topic 3 is thermophysical properties. Ayan. So, si Region, yung nauna? DARFO2. Ayan. So, tama. It's size and shape. Ayan. Mamaya we'll delve into that specific physical property. Next word. Ayan. So, exempted na si Region 2 para ma-present mamaya. Okay? So, next is this one. Ano kaya ito? Tralem Conductivity. Tralem Conductivity. Ayan, si Region 3. Si Benevide Gatos ang unang nakahula or naka-figure out. Ayan. So, it's actually thermal conductivity. Ayan, mamaya, discuss ulit natin yan further. And our last, so Region 2 and Region 3, ayan, exempted na kayo mag-present ng output nyo mamaya. Okay, so yung last word natin, jumbled letters, is this one. So, especially sci-fi, teha, pasiyak. Ano kaya yan? So, ang unang nakatype ng tama ay si, wait. Bakit? In fairness, ang dami. Si Glenn Oka. Ayan, I don't know what region are you from. Sa anong region po kayo galing? Sir Glenn. Pa-type naman po. Para mamaya asing ko yung region nyo para dun sa magpe-present. Si Sir Glenn Oka. Ano pong region kayo? Tama ba? Ayan. So, as a BAFE main office. Alright. So, and hopefully, no, medyo nagising na tayo since nag-exercise tayo and icebreaker. Now, so yeah, so the word again is specific heat capacity, one of the major thermal properties that we're gonna be discussing this afternoon. So again, I'm Assistant Prof. Rina Bawar, and the topic 3 is thermophysical properties of fruits and vegetables. So as I've said, please ready your modules as we go along this topic. Okay, but first, diba, thermophysical, but I wanna, nabanggit din ni Ma'am Elda kanina, we're also gonna discuss physical properties of perishable crops. Now, ano ba yung mga objectives natin for this topic? For this first half of the topic, you should be able to, at the end of this lesson, to first understand the importance of knowing the physical properties of fruits and vegetables. Ba't ba natin ito kailangang pag-usapan? Pangalawa, differentiate the physical properties of fruits and vegetables. And then lastly, differentiate the methods in determining the physical properties of agricultural and biological materials. So physical properties. So this is the most basic and generally the simplest to measure among the characteristics na meron ang ating mga fruits and vegetables. So these are primarily concerned with the physical dimensions of a biological or agricultural material, such as how it weighs and how much space it occupies. So gaano siya kabigat, gaano siya kahaba, dimensions. It includes size, shape, volume, density, and surface area of an object. Now, knowledge of the various physical properties of crops or fish or fruits and vegetables is essential in guiding the development of what? So first, for processing technologies for pest control, disease control, and value adding. For example, nabanggit dyan yung pest control, disease control, nabanggit din kanina ni Doc Elda, yung mga coating. So whether you spray it or you specifically apply some sort of coating or wax, you need to know the surface area. So ganon. And value adding din siya. And then you also need some sort of knowledge on the physical properties for the development of the machinery, the facilities, and handling systems. So you will have to know yung size, shape, density, and the like for screening and separation of handling, di ba? Yung mga machines natin, kunwari, for manufacturing process. So you have to sort yung ating, for example, by size ng mga fruits. So you need to know the physical properties of your commodity. Third is for the evaluation, quality evaluation techniques. So yeah, for quality control of our materials. Is it small? Is it medium, large? So ganon. And then of course, particularly for this training, so for the calculation of the heat transfer and mass diffusion rates of your commodity, you will need the diameter, di ba? Pag nagko-compute tayo ng area, ayan, di ba? Doon sa heat transfer, merong A. So yung A doon, yun yung commodity. Ano yung nangyayari na heat transfer sa commodity mo? Which of course is dependent on the physical properties or dimensions of your fruit. Okay, so actually I have listed this on your module and even defined some, but basically I'm gonna discuss the third one. And kasi familiar na kayo sa angle of repose, angle of friction, volume density, and surface area. So we're gonna really be focusing on this one, size and shape. Okay, so size and shape, these are required to describe an object satisfactorily. So can be determined by graphical methods, pwede rin naman dimensional measurement, so direct measurement, pwede rin projected area method or electronic inspection systems. Now, size, so produce can be sized based on different physical parameters like diameter, length, weight, volume, circumference, projected area, or any combination of this. By the way, yung size and shape, hindi lang siya for the design of your cold storage. Pwede rin siyang gamiting parameter for the evaluation of your produce after storing it. Nag-shrink ba siya? Lumaki ba siya? Nag-bulge? Ganyan. So, yeah. So, next bullet, use in screening solids to separate foreign materials, grading of fruits and vegetables, and evaluating the quality of food materials. So yun na nga, for quality evaluation, no fruit and or vegetable na meron kayo. So actually, isa pa din, hindi lang sa screening solid. Nabanggit kanina din, no, yung packing system ng ating mga commodities. Normally, in a cold storage facility, they are put in stacks. So nakadepende, actually in the mechanical properties, although that's not covered here, no, pero there is a certain measurement for the packaging na hindi yung packaging pattern, anong angle, gano'ng karami, para hindi siya, depende sa fruit of course, para hindi magkakaroon ng mechanical damage yung commodity natin. So yun, nakadepende again siya, of course, sa size and shape ng commodity. So proper pattern packing of our produce. So pwede rin yun. Next, in fluid flow. So in fluid flow and heat and mass transfer calculations, it is necessary to know the size of the sample. It also affects the viscosity and dispersibility and stability of the product. Now, this is particularly relevant. For example, yung term kasi dyan, viscosity. Pag viscosity, more on liquid produced na yun, mga juices. And yung dispersibility and stability of the product, aside from sa fruits and vegetables, na nagagamit din siya sa grains. Pero thinking about it, sa mga cold storage, di ba minsan, pagka nag-design tayo, may mga fans. Di ba? Nag-incorporate tayo ng fan system. So, pagka may mga ganon, yung terminal velocity computation ng isang produce or crop or whatever that is, ang formula niyan, it has this parameter called sphericity na mamaya di-discuss natin sa shape. So para alam natin na ano yung tamang velocity na hindi siya liliparin o hindi siya matatanggal dun sa pinagkakalagyan niya. So yeah, we could use the size for that. And of course, yung heat and mass transfer nga, yung computation ng ating mga ref load. Yan. So may mga, later on sa mga next topics niya, may specific calculations for that. So yun yung for the size. Now, I'm gonna discuss basically yung principle. Makikita nyo to sa as we go along. Yung principle, how do we measure it, as you're gonna apply it. So how do we measure size? So normally, meron tayong micrometer. So familiar kayo dyan, micrometer, ina-adjust lang. It's a direct method. Micrometer measurement method. The other one is projected area method. Paano ba yung projected? Well, of course, by the word itself, may projection na nagaganap, no? Ayan. So imagine with me. So sino rito pag pinapakita ko tong picture na to, may mga estudyante na hindi to alam. So overhead projector. Ayan. Minsan kung improvise o di LCD, yung projector. Ayan. Anyway, so ito yung example. How do we measure the size using the projected method? So what happens is, wait lang. Ayan, what happens is meron dyang some sort of acetate kasi we're gonna, no, not acetate, but you're gonna place your sample right here. So yung acetate yung dati nilalagay dyan. So you're gonna place your sample right here. For example, meron kayo dyang, talandan. Ayan. So what happens is, beside that orange, you're gonna place a ruler. Ayan, kailangan may pardon the drawing. Ayan, ayan. So kailangan meron kayo dyang ruler. Ayan, para pwede nyong i-scale back. Parang yung lang natin, drawing, engineering drawing nung college. Ayan. So how is that? So since meron kayong ruler, meron kayong produced dito, so it'll be enlarged and projected on this area. So ignore nyo lang yung may nakalagay. So magiging nandito na yung kunwari ganyan yung nandyan. And then of course, meron kayong ruler. So ganyan, nagkakaroon lang kayo ng measurement. Nagkataong ito yung pinaka tiresome. Ito yung mano-mano na susukatin ng ruler. Kunwari meron ditong bond paper. Ayan, bond paper na ilalagay dito. Ayan. For example, may bond paper dito. Ayan. So bond paper na malaki. So ganyan yung method. Tapos yung projected nyo na ruler nandito din. Para ma-scale back nyo, for example. So ganyan. That's how projected method works. Okay? Now the other one, wait. Ayan. So for the other one, yung electronic method, ito naman, pwede rito yung 2D machine vision systems like our webcams, ayan. So CCD cameras or charge coupled devices. So yun, pwede rin yung mga 3D machine vision systems. Kung mas level up pa, yung mga other systems like CT, so computer tomography or magnetic resonance imaging, may mga ganong emerging technologies to yung electronic systems to determine size and shape. So yeah, so that's how we determine the size. Now for the shape, so the shape is the one that describes the object in terms of a geometrical body. So yun, nire-relate niya sa isang particular geometrical body, yung commodity natin. So it is also important, again, similar dun sa size kanina, dun sa heat and mass transfer calculations, screening solids to separate foreign materials, ingrading fruits and vegetables, and evaluating the quality of food materials. Now for the shape, particularly for evaluating the quality of food materials, normally ginagamit siya for kung okay ba yung fruit or vegetables natin. Is it baka kasi misshapen or out of shape. Yung mga ganon, dapat bilog pero may makita ka parang boxy, yung mga ganon. So ginagamit for the evaluation of the quality or blocky pala, hindi boxy. Blocky, ganon. So yun, we use shapes to evaluate our food or crops. Ganyan. And then we usually express, so yung shape naman, kung kanina yung size, more on length, width, surface area, density, volume. Ang shape naman, it is usually expressed in terms of roundness, sphericity, aspect ratio, ellipsoid ratio, and slenderness ratio. So how do we measure our commodities. So first, we use chartered standards. Paano ba yung chartered standards? So in this method, we use longitudinal and lateral cross sections of the material with the shapes listed on A. Kaya chartered standard, meron ng provided standard for it or chartered standard. So nandito rin kasama to sa so nakalagay dito, using standard charts, the shape of the product can be defined either by a number on the chart or by descriptive terms. So hindi ko siya ata na-paste dito, pero dun sa handout nyo, yeah. So hindi ko na Ayan, nandito naman yung yung descriptive term. So ito lang yung gagamitin yung mamaya. So for example, for round approaching spheroid. So yung lahat ng details nandito sa descriptive terms. If you want a clearer description for this shape. Actually, for this one, this one is for apples, peaches, and tomatoes, provided by Mosenny in his book. Ayan. And then, ang example naman nito ay, so here are some examples. For example, based dun sa chartered standard. And by the way, you will see me use, since ito, kasama to sa activity natin, no? Pero minsan kasi ang ginagawa, since ito yung may chartered standards, ito, for apples, peaches, and potatoes. Pero for the lack of some materials or standards, kaya ipap-assignment ko rin sa inyo, we sometimes use, for example, itong elliptical, we use this chartered standard or table for the description of other fruits and vegetables. Kasi ganun din naman yung descriptive version niya. Okay, for example, what do I mean? Oblate. Okay, so ano ba yung itsura ng oblate? Sabi doon sa graph, ganito yung itsura ng oblate. Ayan, tapos nandyan, sabi rin sa descriptive table nyo, it is flattened at the stem and at the end at the apex. So paano yung itsura niya? So ganito siya, para siyang yung orange or yung pongkan nyo. Diba? Flattened at the stem and at the apex. So ganyan. Another example is oblong. So sabi dun sa descriptive nyo, dun sa module nyo, it is yung vertical diameter is greater than the horizontal diameter. So example niyan is this one. Diba? Yung watermelon na ganyan. Kalaki. Next is yung conic. So sabi dun sa conic, it is tapered towards the apex. So example niyan will be your strawberries. So it is tapered towards the apex. Diba? And lastly, merong dyan na nakabanggit sa descriptive terms nyo na irregular. So ang irregular, sabi dyan, yung horizontal cross-section departs materially from a circle. Anong example niyan? Ito, yung picture ng ginger. Diba? It departs materially from a circle. So irregular siya. So yeah, so first way for us to describe shapes is through existing standards or chartered standards. Another prominent way to describe shape is through its roundness. So roundness, so it is the measure of the sharpness of the corners of the solids. So by formula, ito yung formula niya. Roundness is equals to AP over AC, or it is the summation of R over NR, which is wherein yung AP nyo, that is the largest projected area of the object in natural rest position. If you remember kanina, di ba may projected area dun sa projector. So ganon, kung ano yung na-project na area, yung projection, so yun yung AP na tinutukoy dito. Yung AC naman, area of the smallest subscribing circle. So, alam niyo na yan, smallest subscribing circle. Now, eto, nandito ata. Mamaya papakita ko. Yung R naman, that is the radius of curvature. So ito, for example, ito yung commodity niyan. Imagine this, that it's the cross-section of a potato. Ayan. So yung R nyo, yung radius of curvature, it is the radius of the corners of your cross-sectional, of the cross-sectional area of your commodity. Now, the big R right here is the radius of the maximum inscribed circle. So this is the one. Largest maximum inscribed, yung nasa loob na circle na mabubuo, na pinakamalaki. And then your N right here is the total number of corners summed in the numerator. Ilang R ba yung ginamit nyo or yung sinum nyo sa taas? So that's the other formula. The other one that you're gonna be using this activity nyo ay this one, AP over AC. So ito siya. Yung AP, it is simply the area of the projected method. And then AC is the area of the smallest circumscribing circle. Yung pinakamaliit na circle na mabubuo na pasok yung buong commodity nyo, yung projected area, projected section. Okay, so that's how we define or compute for roundness or the sharpness of the corners of the solids. Now, for sphericity, ito yung mga pag-measure na, again, nagagamit to for some terms for computation ng ating mga systems. Okay? So again, sphericity is the measure of how closely the shape of an object approaches that of a mathematically perfect sphere. Kung kanina, yung roundness, sharpness of the corners. Itong sphericity, by the word itself, sphere, how close is it? Gan siya kalapit sa isang materially perfect sphere. Okay? So maraming formula na nilagay dyan si Marina. Ayan. Volume of solid over volume of circumscribed sphere raised to 1/3. Ayan. Basically, the working equation is the geometric mean diameter over the major diameter. There was a time, naakala ko yung geometric mean diameter, it's simply, you get the mean. Diba? Ilan yung isasama mo, and then over mo kung ilan yung sinam. But actually, the proper way to compute for the geometric mean diameter is the cube root of your ABC. Okay? Over yung major diameter or A. Ano ba yung ABC? ABC is yung letter A nyo, that is the longest intercept. Yung B nyo, that is the longest intercept normal to A. And then yung C is the longest intercept normal to A and B. Parang, ano yun? Parang, ayan. Para mas ma-picture out nyo kung ano yung ibig sabihin ng A, B, and C na yan. So, yung sabi doon sa kanina, yung A, ito siya. So, that is the longest intercept. Basically, that is your major diameter. Okay? Now, actually, doon sa projected method, it is defined as the longest dimension of the maximum projected area. So, yeah, major diameter. Yung letter B naman natin, that is longest intercept normal to A. So, kung ito yung A, normal to A, this one. So, that is your intermediate diameter. Okay? Yung next naman, yung letter C, that is yung longest intercept normal to A and normal to B. So, that is your minor diameter. In this case, ito yung C. Basically, your A, major diameter, is the length. This is the width, and then this is the thickness, yung letter C, yung minor diameter. Minor diameter is the shortest dimension of the minimum projected area. Okay? So, yan yung sphericity natin. Now, another way to compute for sphericity is through this formula, DI over DC, wherein DI is the diameter of the largest inscribed circle, and then DC is the diameter of the smallest circumscribed circle. So, ito yung DI natin. So, inscribed. So, nasa loob. Largest inscribed circle. Ito yung DI. Okay? And then DC, ito. So, kailangang circumscribing, ma-occupy niya yung buong commodity. That is the smallest circumscribing circle. Bakit smallest? Kasi pwedeng yung circumscribing nyo nandito, di ba? Palaki ng palaki. So, ano pa rin siya? Circumscribing. So, yung smallest dapat. The same goes with the inscribing circle. Kaya largest yung nakalagay. Kasi pwedeng nandito, inscribe pa rin siya. Pero dapat yung largest inscribing circle. Okay? Now, for the others, di ba parang, paano yung iba na irregular? So, yung iba naman, we use the resemblance to geometric bodies. For example, we use prolate spheroid, we have prolate spheroid, and we also have right circular cone or cylinder. Kung isipin nyo yung prolate spheroid, ito yung ellipse, ito, para ma-picture nyo. The ellipse rotates about its major axis. Ano ba ang ganyang fruit? Ganyang medyo pahaba. Lemon, example niya. Parang rugby. Diba? So, sport. Ayan. So, lemon. Ang oblate spheroid naman, nabanggit ko kanina sa Chartered Standard. So, ito, this time around, yung ellipse natin, it rotates about its minor axis. So, ang kamukha nito ay yung grapefruit, o kaya yung oranges, ganyan. So, yung last naman is the right circular cone or cylinder, minsan cylindrical. This one is a frustum cone. So, ang example nito ay mga carrots, kapag cylindrical naman, yung mga cucumbers natin. So, yeah, that's how we do it. For the others naman na walang specific one shape fits all. Diba? Parang ito na lahat. What happens is we divide it. For example, in this picture, that's actually an avocado. So we divide it into segments of different shapes. Kapag i-characterize natin siya, we have a segment of a sphere right here, another segment of a sphere right here, and then frustum right cone, frustum right cone, frustum right cone. So ganon. Ganon yung pag-characterize no shape. Alright? So malinaw ba? Now, yung another prominent na physical property is yung volume and density. They always go hand in hand. I just want to mention this for this training. Yung common, yung types of volume and types of density na we are very much familiar of are yung bulk volume or bulk density. We have the apparent one and then the true or absolute one. Now, I want to discuss this further quickly lang to discuss ano bang major differences nitong tatlong to, nung tatlong density. Since in density actually, alam niyo naman na to, no, mass over volume. So, kilogram per cubic meter. Pero ano bang pinagkaiba nitong tatlo? Anong pinagkaiba ng bulk sa apparent sa true? So, for example, you have a crate right here. Ayan. So, diba normally mga naka-crates yung mga ano natin, commodity. Ayan. So, for example, you place yung mga oranges nyo dyan. Let's example 3. Ayan. Pardon the drawing. Ayan. So, for example, kapag bulk na tinutukoy, alam natin, if you imagine just one orange right here, we know may dalawang pores na nag-exist dyan sa container na yan. Pores, internal pores, nung each orange, diba? Yung orange natin, may flesh, may mga seeds pa nga sa loob, tapos may peel. So in between the flesh, the peel, and the seeds, meron mga internal pores. So yun yung tawag natin, internal pores. Now, between those oranges, now, for example, imagine with me, no, na puno na yan. Puno. Kunwari, maraming laman yan na oranges. Di na mag-drawing. Ayan. So, mayroon namang mga pores that exist between the oranges. So we call that external pores. So we have internal pores within each commodity and then external pores between the commodities. Now, if we define bulk volume or bulk density, it includes the internal pores and the external pores. Okay? Malinaw ba yon? Now, yung isa ng klase Kaya siya bulk. Okay? Kasama niya lahat in bulk. Now, yung apparent naman, so kaya siya actually apparent. Normally, we think about this as the true density. When in fact, apparent siya. Why is that so? Kasi if you remember, sa mga test, liquid displacement, platform, scale displacement, yung may water, di ba? Kunwari, meron kayong cylinder, tapos ilalagay niyo yung sample niyo sa loob, tapos may displacement, water displace. Archimedes principle, di ba? So, yung natanggal na displaced, volume displaced, we think that it's the true volume dati or true density of the material. In fact, apparent siya because actually, you exclude the external pores. But still, there exists some sort of pores within the material. So yun yung apparent density. You still consider the internal pores. But you are able to exclude through the method that you use. For example, nga yung liquid displacement. Na-exclude mo na yung doon, external pores. Okay? Yung true or absolute or skeletal density, ito naman, kung ito, internal plus external, ito, internal, ito yung true, just the material. Walang pores. Paano to? Paano to ginagawa? Kaya minsan, ang tinatawag ko sa kanya, kung hindi true density, minsan skeletal density, bone density, or absolute density, meaning to say, it's the actual density of your fruit material. Now, how do we measure it? Yung bulk, we measure the bulk density using a bulk density scale. Kaya, you just have to have some sort of known volume, you weigh it, di ba, kilogram per cubic. Kung sa known, you weigh it, yung known weight over known volume. So, bulk density na agad yun. Apparent, yun na nga, liquid density or any Archimedes principle application. Now, yung true density, normally ginagamitan to ng, kung ito, liquid displacement, ito, gas displacement, para ma-exclude yung parameters ng pores inside. Normally, may mga helium, yung mga klase, ano bang makaka-penetrate yun. So, helium gas. So, basta, kung ito ang nadi-displaced ay liquid lang, ito, kailangan may some sort of penetration dun sa commodity para yung absolute lang, yung true density lang niya yung i-measure. Alright? So, yun lang yung sa dyan na portion na I wanna clear. And then, of course, you are familiar with the term surface area. Basically, that's the area of the topmost layer or the surface. So yeah, yun yung mga known physical parameters for fruits and vegetables. Now, for our activity 1 na na-exclude, exempted na mag-present later si regions 3 and 4 and yung main office. So, nakalagay dyan. So, maganda rin. Actually, maganda kasi na we, as an outcome of this training, we are able to collate ano ba yung mga standards na ginagamit na for the respective region. So, ito, yung part 1, more of an assignment. Hindi natin ito gagawin dito. Kasi more, nakalagay dyan, depending on your assigned area or region, check for established standards for shape, determination of the fruit or vegetable most prominent in your region. Upload your gathered standards in this Google Drive. Ayan. So, pa-type lang. Makikita niyo yung pag tinype niyo yung website na yan, https tinyurl.com/buffettraining2022. Once you open that, makikita niyo may mga, hindi pa ako tapos, paggawa na lang ng folder, may counting folder pa lang yun nandyan. So, pag nag-submit kayo ng mga output niyo for this topic, so, pa-upload na lang on your respective folders. Okay? So, dyan, pa-upload. Actually, I think dun sa ano ba na-expect ko dito? Dun sa, ayan, nung nagbigay ako example dun sa module nyo, ito yung for example, ito kasi yung kay Mosenin. Pero upon checking, there exists from a study, meron chartered standards for onions. So, let's check and see what kung ito, yan, may mga onions, may mga existing standards. So, yun yung i-upload nyo. Depende, yung sample na to for onions. So, how about for lettuce, for other fruits? Diba? Dapat meron tayong set standard nung ito yung acceptable or ito yung shape na ayun, yung hindi misshapen, kumbaga. Alright? So, yun yung partly assignment activity nyo sa part 1. Yung, ito yung gagawin nyo, di ba nagpa-ready ako ng fruit or vegetable sa area nyo, di ba? Naka-ready na ba? Pa-ready naman. Nagpa-ready rin ako ng ruler. Ano pa ba? Ayun, tsaka nagpa-print ako nitong module. So, kasi bakit? Using imagery, ayun, sabi ko rin, i-download nyo na. So, by now, dapat naka-download na sa inyo yung imagery. Because together, we're gonna explore imagery. This is open source, so kaya madali i-download. And then, you are going to determine the roundness and sphericity of the fruit or vegetable you have prepared, whatever that is. And then you're gonna use the provided equations na diniscuss kanina. So, di ba may mga diniscuss ako na formula? Actually, detailed yung module nyo. Ayan. So, kung anong formula yung gagamitin nandyan. Alright? So, pa-ready ng mga fruits nyo. Now, what I'm gonna show you is paano gumamit ng imagery. Wait. So, ito kasi ay kapag ang OS nyo ay Mac, nakahiwalay siya. Kapag ang Windows, nakadikit nyo yung file. Pero kapag Mac, yan, baka hinahanap nyo, nawawala. Ito, nakahiwalay siya. Kasi depende kung anong naka-open na file, yun yung mag-a-appear dito. Ayan. So, pa-ready. Now, I'm gonna briefly discuss yung method of using this software. Tapos later on, you're gonna do it on your own fruits and vegetables na ni-ready nyo. Okay ba yun? Para ma-apply nyo. Now, wait. So, so you open yung mga dinownload nyo na open na ba? Pa-open naman. Wait. Hindi pala, wag niyo pala muna i-open. Ako muna, i-discuss ko muna. Tapos naka-step by step naman sa baba. Need ng access code. Access code po ba ito sa yung pag-download? At least hopefully one from each region, magkaroon sila ng working imagery program. Wala po, kasi may nagtatanong, no, need ng access code. Ano po siya? Open source. So, walang hihingin sa inyo. Kailangan lang i-install. Of course, kung may password po yung PC nyo or laptop, you have to permit the installation of the program. Ayan. So, i-demo ko muna, bago nyo i-apply pala, mamaya nyo i-apply, i-demo ko muna paano siya mag-work. So, para mas madali, side by side natin yung module na meron kayo. By the way, yung module na nandyan ay similar to din sa material na pinaprovide namin sa isang course. Ito po ay yung thesis ni Ma'am Camille. Thank you, Ma'am Camille. Nandito siya. Ayan. So, step by step natin, no, para sundan natin kung ano yung nakalagay sa procedure. So, open. Now, an item like ruler whose unit is clear should be photographed with your object together. Similar din sa projector kanina, kailangan may katabing ruler yung object nyo. Kaya sinabi ko ba? Parang sinabi ko naman, no, may ruler din dapat. Ayan, para pwede nyo i-scale back to the actual measurement. Okay? Now, for example, this one. I'm gonna upload one. Okay. I'm gonna open this sample. Okay. So, kung gusto niyo shortcut para sa Photoshop, Control minus para mag-minimize. control plus, yung after 0, di ba? Minus, tapos, or control equal pala sa ibang keys para mag-maximize. So, control minus. Ayan. So, ayan. We have this picture right here. Nakalagay dyan, kailangan may ruler. Medyo wala nang mahanap na ruler. So, dapat clear yung ruler dapat. It should be scaled bar for the image. The ruler and the topmost surface of the material should be leveled. So, ito, may kwento kami dito. Short kwento lang. May kwento kasi kami ni Ma'am Camille dito. When we were preparing this material or exercise before, medyo nagtatak kami. Kasi for some reason, pag ginagamit namin yung software sa grains, tama. Pero pag ginagamit namin siya sa Apple o sa ibang commodity, hindi siya nagtatama. Parang kino-cross-check namin yung results ng software. Tapos, yun, na-figure out ng husband ni Ma'am Camille, kaya naka-emphasize dito. So, the ruler and the topmost surface of the material should be level. Kasi, it works with the pixels, yung software na ImageJ. So, yung picture natin, merong, sabi nga, ng husband ni Ma'am, may depth of perception. So, nung dati kasi, ang ginagawa namin, kaya hindi namin natatama yung readings, it's because, for example, ito yung sample. Tapos yung ruler nasa table, naka-flat. When in fact, ang kumukuha kami sa taas, top view. So may variation na sa pixel. 'Di ba yung quality? Kasi nasa baba yung ruler. May lalim, may 'di ba, may height yung apple. So, one note, when you do take a picture of the sample na i-run nyo, kailangan, hindi lang halata dito sa picture, pero yung ruler at that point ay nakataas, naka-level. I mean, the ruler, kung ito yung topmost layer ng apple nyo, ito, kunwari ito yung table, ito yung apple, naka-level dito yung ruler. Okay? Tapos tsaka nyo kukunan sa taas. Alright? So, yun yung number one step. Next is, sabi dyan, we have to convert the image to grayscale. So, pupunta lang kayo dyan. So, step by step to, nakasama naman to sa printout nyo. So, masusundan nyo siya. So, file, sabi dyan, image and then type, tapos 8-bit. So, gagawin nyo siyang grayscale. Okay, so magiging grayscale lang. And then, next step, draw a line over a 1 cm section of the ruler, then analyze and then set scale. So, sabi dyan, draw a line. So, medyo malabo yung ruler ni Ma'am Rina. No? So, dito, kailangan daw mag-set mag-drawing kayo ng 1 cm na ruler. So, click nyo lang yung, yung line. Kita nyo naman, naka-share screen ako, no? Nasusundan ba ng lahat? Ayan. So, dun sa ruler, ito yung 1 cm. So, we're gonna create a line from one point to another. Actually, mamaya, ito. Drawing tayo ng isa. Dito, tingnan nyo mamaya. Once that, so nag 1 cm tayo. So, may mga lumalabas kasi dito na mga dimensions later on, itong section na to. So, punta muna tayo, sabi dun sa steps, sabi, nag-draw ng line. So, nag-draw na tayo ng line, 1 cm. And then, go to Analyze, Set Scale. So, punta tayo sa Analyze, tapos Set Scale. Nandun din siya, ayan. Analyze, Set Scale. So, now, ito, yung 176, yan yung pixel, yung distance in pixels na na-determine. Hindi nyo yan lilikutin. Okay? What you're gonna do, alam mo, yung known distance, alam mo na yan ay 1 cm. So, gagawin mo siyang 1. Okay? Yung pixel aspect ratio, you retain it as 1. Tapos, alam mo na yung unit mo ay centimeter. So, gagawin mo siyang centimeter. Now, yung global, ang sinasabi lang yan, kapag global, yung scale na gagawin mo, it will be applied to the other windows na naka-open na ImageJ. So, we can click that up. So, ito lang yung kailangan niyang baguhin. Yung distance na 1 and then unit na centimeter and then global. So, okay. So, ngayon, kailangan kasi nating turuan yung system na ito, Ito yung 1 cm, okay? Pag binasa mo to, 1 cm to in real life. Kaya, kunwari, nag-draw ulit tayo ng line. From this point, for example, from 80 to 110, makikita nyo dun sa taas, dito, ayun, dun. May length na lalabas. So, malalaman niya. So, from 80 to 110, na-determine, sukat niya na 2.95 centimeter. Okay? Ayan, pag lumaki, 3.98. Ayun, lumalabas dun. Ayun. Ayan, length, angle. So, ganon. So, ganon din. Kasi later on, we want to know we're gonna determine the, di ba, projected area. Di ba? Dun sa formula ng roundness natin, sabi ko, ayan, eto. Yung AP, we need to know the projected area. The actual projected area. So, gagamit tayo dyan ng image J. Actually, yung formula na to, over AC, pwede nyo rin kasing palabasin yung major diameter or circumscribing circle. Mamaya tuturo ko. Now, doon mo tayo sa processing. Ayan. So, alam na natin na-define na natin yung actual scale to the system. Now, what we're gonna do, sabi sa steps, so balik tayo sa steps, image and then duplicate. Now, ito pala yung isang note. Kung kanina, isang importanteng note ay ka-level dapat nung ruler, yung apple or nung produce nyo, kung ano man yung height niya. Now, yung isa pang, medyo may mistake ako dito nung pinrepare ko to. Mas maganda, yung table, may mga grains yung table na nakuha ko, pinagpatungan ko. Mas maganda, pag nag-take kayo yung picture, clear yung yung pinagpapatungan or yung background. Kasi lalabas yan mamaya. Another thing is, of course, mas magandang klase ng camera, mas okay. I remember when we first did this, yung isang exercise, merong sa klase na iPhone, merong Samsung, pero sa lahat ng pictures na nakuhanan ng mga estudyante, ang pinakamaganda na na-process nila, pinakamadali actually, ay yung sa Oppo. Maganda yung quality ng picture niya. So, that being said, crucial din, okay, yung quality ng picture, di ba? Ganda naman sa image processing. Now, yun, mas maganda, for example, in this case, medyo light yellowish yung sample. Ang background ay dark. And vice versa. Kung dark naman yung yung sample nyo, kailangan medyo white or bond paper yung likod. Kasi tulad nito, medyo naging issue to gawa ng may shadow. So, kailangan kasi nating matulungan yung software na ma-distinguish niya itong commodity. Yung ating sample lang. Okay? Paano yun? Kasi ganito yung mangyayari sa next step. So, kailangan kung light, dark yung background. Kung dark naman yung commodity nyo, light yung background nyo. Now, ito, number 5. So, yan. Yung duplicate. For example, we're gonna be working on this section. Para hindi tanggalin na natin to. For example, yung one apple lang. Ayan. So, what we're gonna do, sabi dyan, select the area to be analyzed. Let's take, for example, this one. So, we go to image, and then duplicate. Kasi okay nila. Ayan. So, ito na siya, yung apple natin. Now, yung number 5, sabi dyan, threshold the image of peel using manual settings. So, image, adjust, and then threshold. So, what we're gonna do is image, adjust, and then threshold. Ayan. So, what we're gonna do is, ayan, makikita nyo, dahil sabi ko nga, di ba, medyo problematic yung table, na-determine niya kasi na grains din or measurements yung mga grains ng wood or ng table. So, mamaya, may paraan yan para ma-exclude. Tatanggalin natin yan. Pero ang gusto natin is we want to define this area ng ating commodity. So, how we do that? Ayan. Ayan. So, ayan. By the way, disclaimer, no? Nung nakita ko to, hindi na ako nakapag-picture. Magiging, mamaya makikita nyo tong source of error. Yung grains kasi napadikit dyan. Anyway, ito lang naman yun. Okay, mas maganda, again, walang grains yung table nyo. Basta ang goal lang is makabuo kayo ng clear na nasasakop yung buong commodity. Okay, so we apply it. So ayan, basta pasok na. Tapos maybe you're wondering, paano to? Pag binasa natin yung area, may mamimiss kasi hindi ito naka-shade na red. Maya may i-click tayo para kahit wala siyang, kasi pagka tinodo nyo, ayan, dadami yung bilog eh. Mako-connect nyo yung labas, kahit kung sasagarin nyo. So, okay lang yan. Meron tayong pwedeng i-click na parameter mamaya na in such a way na kahit meron sa loob, itong buong area na to yung i-read niya na projected area. Okay, we apply it and then we set it. Okay. Ayan. So, meron na tayong threshold. Ayan. So, ito, katulad ng picture dyan. Now, we want to analyze. Again, pupunta tayo. Ang gusto natin makuha ay projected method. Projected area. So, we go to analyze. And then analyze particles. Sabi dito, ayan. Sundan lang natin na. Sundan nyo ako as I speak. Dun sa handout. Ayan. Now, ito, the default size in square centimeter is 0 to infinity. But to disregard outliers, ito yung mga outliers natin. Ang gusto lang natin ay itong malaki. The minimum particle size can be changed. So, ito yung particle size. Toggle show outlines. So, dumuna tayo sa papakita ko. Pag hindi natin ito binago, pag ginawa natin itong 0 to infinity, kahit pinakamaliit, babasahin niya yung projected area. Ito, lahat to babasahin niya. Okay? For example, i-do natin muna natin. For example, ayan. Napakarami niyang shinow na maliliit na particles dito. Ayan. So, marami siyang ilang bilog, 11,000 na area yung na-detect niya. Ang gusto lang natin ay yung isang apple. So, kaya lilimitahan natin yung, don't save, lilimitahan natin yung scale. Okay? Hindi natin to gagawing 0 to infinity. So, kapag nag-analyze tayo, for example, punta tayo, analyze particles, gawin natin na yung malaki. For example, 1, assume natin na, ito medyo partly trial and error, depende dun sa ano nyo, no? Pero relatively, let's say, gawin natin yung 100. Ayun, isa lang yung nakuha niya. Pero, wala kasi tayong do nothing yung ginawa natin. Don't save. Kaya pinakita lang niya ay total area. Now, ito yung pwede nyo i-tweak para mas marami kayong makuhang results. And we want, for example, dun sa formula ng roundness. Kasi yung roundness, ayan. Yung formula ng roundness, that's projected area, AP over AC. So, gusto natin makuha yung AC or the smallest circumscribing circle. In this case, that is the major diameter. So gusto natin mayroon din tayong major diameter. So pwede nating dagdagan. Kasi yung kanina, kaunti lang. Tanyo. Run ko ulit. Okay. Kasi show nothing ginawa natin. For example, outlines. Ayan. By the way, ito, naka-check na pala. Check ko na kanina. Yung include holes, ito yung include holes na tinutukoy. Pag hindi ko siya sinama, hindi niya isasama tong area na to. Dun sa pag-run nung area. Okay, so include holes dapat. So, ayan. At yung sabi ko source of error nung niran ko to. Ayan, meron grains, pero ignore na lang natin muna. Pero yon dapat kasi clear yung table na gagamitin. So, ayan, makikita nyo, ang summary niya lang of results ay total area, average size, median, ganyan. Pero pwede nyo dagdagan yan. Pwede nyo isama yung major diameter, roundness, actually may roundness din dito. Don't save. So, run ulit tayo. Paano natin papalabasin yung mga yon? Dun sa set measurements. Kung tayong set measurements, okay, tapos, lagay nyo yung shape descriptors, fit ellipse. Ayan. Kasi yung sa fit ellipse, nag-fit siya ng major diameter. Para pag nakuha nyo yung diameter, makukuha nyo yung circumscribing area. Ito, yung AC. Okay? So, ayan, marami pa kayo pwede i-check. Pero yun lang yung muna i-check natin kasi yun yung kailangan natin dito. Actually, marami pang features to, pero yung basic lang yung papakita ko this afternoon. So yeah, analyze particles. Tapos, let's show outlines and summarize. So magra-run siya. Ayan. So this time around, bukod sa total area, meron na kayong major diameter, minor diameter, angle, circularity, solidity, and median. Ayan, meron din yung roundness at saka ayan, yung sa isa. So, ganon. Lalabas na agad yung major diameter, which you could use for the computation of the AC dun sa denominator. And then, meron na kayong area, which is yung projected area sa taas. Okay, kukopihin nyo lang. So, yeah. Now, kung dalawa to, ganun lang, di ba kanina nung niran natin, nung niran natin, tas nag-set tayo ng limit. Kung dalawa to, dalawa lang yung rows na i-display niya. Parang yung nandun sa kay Ma'am Camille, ayan. I-display lang niya kung ilan yung madedetect niya na areas or yan, mga projected areas na nag-fit dun sa sinet nyo na size ng particles. Okay? So, yon. Ngayon, looking at my time, stop share muna. Ang time ay 4:21. First topic pa lang po ito. May pangalawang topic pa. So, mukhang ipapa-assignment ko na lang. Sir Luther, okay lang ba yun? Assignment na lang ito ulit. Oo. Pero dun sa mga, kung meron man kayong dala ngayon sa office na mga, kailangan nyo lang picturean ngayon. Madali naman siyang i-process. Oo, bale, I was gonna set some time para gawin nyo siya ngayon eh. Pero, ayun. Okay lang ba? I-assignment ko na lang. So, yung unang activity nyo, nakalagay dyan sa module nyo ay ayan. So, una yung sa shapes. And then yung pangalawa, ayan. Using image ray, determine the roundness of the fruit vegetable you have prepared. Use this equation. And then use, and then determine the sphericity. Yung sphericity, ayan, meron kayong major diameter at minor diameter. So, mako-compute nyo din gamit yung image ray. Okay? So, in the software, ayan, nakalagay din naman dyan. Okay ba yun? Malinaw ba tayo doon sa physical? Ay, hindi pala ako nag-share. Ayan. So, ayan. So, sabi doon sa module nyo, ayan, AP over AC. So, using this equation, so meron ka AP, yung makukuha nyo, and then AC, meron kayong major diameter, you simply compute for the area of that circle. Now, for the second requirement, compute for the sphericity using the following equation. So you have DI over DC, yung DI nyo, largest inscribed circle, and then yung DC nyo, diameter of the smallest circumscribing circle. In the image J, that is simply your major, minor and major diameter na nandun sa results nyo. Okay, tapos nandito naman yung detailed steps for your activity or assignment. Okay ba yun? Malinaw ba yung pag-determine ng shape? May tanong? Bago tayo pumunta sa thermophysical. Okay pa kayo? Nandiyan ba kayo? Sige. Pa-react naman kung ano yung nararamdaman nyo ngayon. Yan. Are you shocked? Are you okay? Are you in love? Ayan, heart? Tignan ko ako nandyan pa talaga kayo. Or party dahil konti na lang magpa-5 na. Ayan, pero tapusin natin to. So, assignment muna to per region. Doon sa nakalagay. Wait lang. Thank you. Ayan, so yung mga thermophysical properties, thermal conductivity K, thermal diffusivity alpha, and then specific heat capacity CP. Not just of the commodity actually. Again, it's a interrelationship of the cooling medium, which is usually the air or chilling air, of the produce and of the packaging material. Okay, so these values are interrelated as Cp is equal to K over rho alpha, wherein the rho is density of the material. So we have specific heat capacity is equal to the thermal conductivity over density times the thermal diffusivity. Okay? So may interrelationship. Actually, remember this. Later on kasi, dun sa mga, kasi I'm gonna show you yung principle, yung methods of measurement. Mamaya, marami akong papakita, hindi may mga methods of measurement for CP, tapos, and then thermal conductivity. Pero rare yung thermal diffusivity. Normally kasi, this formula is used na using the known specific heat capacity and thermal conductivity. Okay? Ayan, nandyan din yun sa module niya. Ayan. Anyway, so thermal properties of materials involve parameters associated with the three modes of heat transfer, which is, of course, you're very much familiar with these three: radiation, conduction, and convection. Now, ito yung, ayan, by picture. Now, let's look into this in terms of fruits and vegetables. Okay? So now, sabi dyan dun sa, I think dun sa module nyo naka-descriptive. Tinable ko lang dito sa presentation. Now, for conduction, so sabi dyan, movement of heat to or from the produce due to temperature gradient. So basically, that is the transfer of energy from a more energetic particles of a substance to the adjacent less energetic ones, okay, as a result of interaction between your particles. Now, in fruit, nakalagay dyan, like all materials, conduction of heat is dependent on the produced thermal conductivity, which is also affected by factors like the fruit moisture content and porosity. Okay? Yung convection naman, so this one, sabi dyan, involves the combined processes of conduction or heat diffusion and advection, which is the transfer by bulk fluid flow. So ito naman, yung mode of transfer of energy is between solid surface and the adjacent fluid that is in motion, and it involves the combined effects of conduction and fluid motion. Sabi dito, dun sa explanation sa fruits, in post-harvest handling of produce, the bulk fluid is usually chilling air from the refrigeration unit. So normally, yung bulk fluid flow natin is, or yung convection, kasi conduction, that is through our chilling air. In hydrocooling cases, it is the chilled water. The chilling air is forced to flow through and around the stock produce to extract the excess heat from the produce and circulate back to the refrigeration unit to reject the extracted heat. Okay, so paano ba yan? Di ba nabanggit kanina, sabi dyan, it is a combined process of conduction and advection. So, or conduction and fluid motion. So, if you picture out, for example, let's take for example yung chilling air ng refrigeration unit. Tapos kunwari, meron tayong freshly harvested na, mangga, ganyan, mangga. Ayan. So, what we do, energy is first transferred, kapag nilagay natin siya dun sa refrigeration unit. So, energy is first transferred to the air layer adjacent to the surface of the produce. Yun ay conduction. Yung adjacent layer that is in touch with the circulating chilling air. And then afterwards, energy is then carried away from the surface of your mango by convection. This time, ito na yung fluid motion within the air. Okay? Nandun naman yung convection, which removes the heated air near the surface and replaces it with cooling air. Now, or cooler air. Tapos ito, may dagdag lang dito sa baba that, yun nga, what the chilling air or the refrigeration system does is it circulates back So yung excess heat, it circulates back to the refrigeration unit, which is extracted as heat. Now, itong radiation, so this is the transfer of heat through electromagnetic waves. So unlike our conduction and convection, the transfer of energy by radiation doesn't need an intervening medium. It is through electromagnetic waves. Yan. Ang daming electromagnetic waves sa paligid natin, diba? Yan. From radio stations, yan. From the computer, cell phone, another electromagnetic waves dun sa electromagnetic spectrum natin. Part of it, meron sa radiation. Ayan. So, yun. Kaya kapag napansin nyo pagka sobrang init, ano yung daan? Napansin nyo ba yun? So, yung electromagnetic waves yan. Anyway, so going back, kung yung kanina kasi, yung conduction convection, pwede siya sa storage. Ito, yung radiation, normally, it happens pre-harvest. Kasi normally, itong ginagawa niya sa cold storage, post-harvest yan. So, sabi dyan, nakalagay, this form of heat transfer is crucial before harvest when fruit is hanging on the tree. Radiant waves from direct sunlight. So ito na, yung radiation normally is experienced by our commodities kapag na-expose siya sa araw. Especially during summer months, can result in sunburn damage and losses due to sunburn damage. Damage. Period. Losses due to sunburn damage is a major source of economic loss in the marketing of the fresh fruit due to the fruit discoloration and variation of the texture. Okay, so next naman is yung another bullet about thermal operations. So thermal operations in the post-harvest deals with living materials characterized by properties with strong spatial and temporal variability. I have to mention this because there are some, paano ba nung ibig sabihin nito na spatial and temporal variability? Because there are some na merong, the physical structure of the food varies inside. Okay? Merong change in time and space dun sa loob. Okay, what do I mean? For example, we have fruits like mangoes na merong mga seed. So, bukod doon sa flesh, may seed. May kernel, tapos may seed, tapos may flesh, tapos may peel. So, for such kind of commodity, there could be significant property differences between the seed and the flesh parts of the fruit. So, it is important that you know the cooling history of the flesh part, of the stone part. So, ganyan talaga ang ating mga agricultural materials, no? Very diverse, maraming kailangan i-consider. Actually, even the stone flesh interface, kailangan may accurate determination of the cooling properties or thermal properties. Ayan. So, what else? Ayun. So, next bullet ay nakalagay dyan, thermal processing involves transfer of heat, energy to or from a product. Ayan. Table 1 summarizes some of the most common thermal treatment or particularly cold treatment processes during post-harvest. I'm pretty sure you're very familiar with all of this. Tadaan ko lang ng mabilis, no? By the way, question lang pala sa pwede ba akong mag-exceed ng 5? Or para or question lang sa natin. Paano kaya? Or either, pwede po ba? Lalo na kasi may mga nasa offices. Crystal? Sir Mark?
Mga ilang minutes po kaya ma'am yung tansya niyo pang extension po?
Siguro mga 20, ganyan. 20 to 30.
Sige po. Sige ma'am, pwede po. Sige.
Ayan. Or baka naman mas mabilis. Ayan. Pasadahan lang natin. Okay, thank you, Mark. Ayan. So, ito yung mga common cold treatments. So, we have pre-cooling. So, your fruit temperature is brought down to the recommended storage temperature in the shortest time possible to reduce detrimental fruit physiological and biological changes. So, ito yung pre-cooling is the quick removal of field heat na experience ng ating commodity after harvest of the crop. So, example nitong pre-cooling, it could be room cooling, pwede ring forced air cooling, vacuum cooling, or kung didip nyo sa cold water, so hydro cooling or spray cooling or package icing. So, pero ang pinaka-often ay yung forced air cooling or ilalagay sa ref. Ayan. So, it is the most favored pre-cooling technique. Next naman is yung refrigerated transport. So fruit are transported in reefers that are maintained at recommended temperature and relative humidity of a particular fruit. So especially, of course, kapag distant for yung fruit for distant markets, so they should be kept cool at the optimum condition during transportation. And we use reefers or refrigerated containers for that. So yan, yung reefers natin, just like this one, they are designed to distribute, chilled air from the floor via specific T-shaped decking. Dapat, of course, yung air delivery system natin should be powerful enough. Binabagay nyo kanina yung mataas yung power requirement talaga. To ensure, but because kailangan talaga yun for us to ensure na may enough and uniform flow of air through the stack of produce na ilalagay natin dito. And then, yung next is yung refrigerated storage. So, fruits are kept in a room maintained at the recommended temperature and relative humidity for a particular fruit. So, again, we use refrigerated storage room to keep the quality of our produce beyond their normal shelf life. So normally, the chilled air is circulated in their stock by use of air driving equipment, and heat is removed from the produce and other sources by the cooling unit or refrigeration unit. Okay, next naman is, by the way, yung nabanggit din kanina, no, this is yung mga refrigeration units natin. They are affected by the design of packaging boxes or packaging material. Diba? Because if there is a non-uniform flow of air inside to cool your, or there's an even cooling na ating produce, it will result to loss of product quality. So ayaw din natin na. Okay? Yung last naman, ito, refrigerated retail display. Fruits are displayed in cabinets on shelves maintained at the recommended temperature and relative humidity conditions. So ito, nakalagay dyan, retail display. So ito yung mga nasa mga supermarket, ayan. So, our stores, diba, for display. Now, aside from keeping the produce cool, so display coolers, actually ba napansin niyo yun sa mga supermarket, yung display coolers, kailangan nakikita mo pero at the same time, may access ka. Nakukuha mo kasi bibilhin mo eh. So actually, yung mga ganong klase ng refrigeration retail display, meron tayo tinatawag doon na insulation barrier called air curtains. Okay? It is a non-physical barrier between the chilly air inside the case or the storage rack and the warm shop. So yeah, merong air curtain in between for this one. Okay? So yeah. Here are for thermophysical properties of fruits and vegetables. So the heat exchange between a fruit and its surrounding depends on the thermal properties of the fruit and the surrounding cooling medium. So the most important properties to analyze thermal processes are, so ito yung common. Ito yung tatlo na i-focus natin. Thermal conductivity, we have thermal diffusivity, and then specific heat capacity. Actually, yung density of the produce in isang parameter din na important. And then that is not just of the produce, pero dapat din talaga i-consider mo sa packaging material and dun sa cooling medium. Okay, so in addition, ito, tulad nung nabanggit kanina, no, na-cover naman to ni Doc Elda ng thoroughly, no. In addition, the respiration and transpiration properties and the accompanying heat and moisture generations during storage of fruit are crucial to design and optimize thermal processes in the post-harvest. So yeah, it's a correlation, okay, and control of all these parameters para optimal yung ating end product. Okay, so ito, the thermal properties of the cooling air medium and most packaging materials are well established and can be effortlessly obtained from literature. So in terms of cooling air, tsaka yung mga packaging, yun na nga, you could obtain them through literature. However, on the other hand, yung mga produce natin, bilang sila ay mga biological materials, they have thermal properties that vary with time, temperature, and moisture content. Makikita nyo dun sa mga formula mamaya, dun sa formula merong temperature parameter. Meron, kasi it varies depende sa temperature, dun sa ambient temperature nung pinagkuhanan or kung saan siya, yung working temperature niya. Pati yung moisture content, nandun siya sa formula kasi yung moisture content significantly affects the thermal properties. So yun. And another note, pag nakita niyo yung tables na sinend ko sa module niyo, the absence of any consistent trend is apparent. So, mahirap talaga mag-set ng trend for fruits and vegetables. Ayan. This implies or signifies the caution required when using literature data in prediction models. So yun, yung kaya siya empirical equations. There are certain parameters and conditions that the equation is supporting. Okay, that it could be considered for. Okay, also, there may be considerable difference between fruit parts. Ito yung nabanggit ko na, ayun, especially for fruits with prominent stony core surrounded by fleshy or pulp tissue like mangoes, cherries, and plums. So yun, separate consideration pa kung merong distinct parts yung mga commodities natin. Okay? So, ito. So, differentiate ko lang yung tatlo na important thermal properties for fruits and vegetables. Una, so we have specific heat capacity, thermal conductivity, and thermal diffusivity. For the specific heat capacity, so this one, it determines the amount of heat needed to raise the temperature of 1 kilogram of mass by 1 Kelvin. Or pwede rin by 1 degree Celsius. So, yun. Yung specific heat values niya for yung table, different fruits and vegetables na binigay ko, it ranges from 1.72 to 4.05 kilojoule per kilogram Kelvin. So, ito, equal lang to, no, doon sa table kasi I think yung isang table, kilojoule per kilogram degree Celsius. It's 1:1 lang naman yun, kaya okay lang. Okay, and the average value is 3.74 kilojoule per kilogram Kelvin. Now, ito naman yung third row. Ito yung sa mga studies, ito yung na-notice or mga conclusions nila ng mga parameters that affect this thermal property. So, specific heat values have been reported to increase with increase in fruit moisture content. So, habang tumataas pala yung moisture content, tumataas din yung specific heat values. There were specific crops na na-observe to. And then a similar trend is reported with regards to temperature. So meron din naman na ibang commodity na habang tumataas yung temperature, tumataas din yung specific heat capacity. Pero based dun sa analysis, dun sa mga different publications, the effect of moisture content has however shown to be stronger compared to the effect of the temperature. Mas dominant yung effect ng moisture content kaysa dun sa working ambient temperature niya. Actually, I just want to cite, no, it's not automatic. I want to reiterate na there are particular fruits. For example, there were by Kumar sa mga tomatoes, nakakita sila ng increase in specific heat when there was an increase in temperature. Pero meron namang iba, like for sising, nag-report din siya na there was no effect in temperature on specific heat for unfrozen food products. So depende talaga, kailangan talaga ng sufficient literature search and consideration bago ma-correlate lang. Hindi siya for all, ibig sabihin. Okay, different cultivars of the same fruit actually nakadepende rin siya sa cultivar. Merong isang study, meron siyang kinonsider na 1, 2, 3, 4, 5 apple cultivars at the same temperature, at the same moisture content. Pero nagkaroon pa rin ng differences dun sa specific heat. Okay, so again, dun sa material composition yung or microstructure yung dahilan kung bakit sila nagkaiba. So yeah, so that's for your specific heat capacity. Now for thermal conductivity, this measures the heat conducting ability of a material. So materials with low thermal conductivity have lower rate of heat transfer than materials with high thermal conductivity. Mag-jump na ako doon sa thermal diffusivity, no? Kasi medyo para differentiate na natin sila. Sabi kasi doon sa thermal diffusivity naman, thermal diffusivity measures the rate at which heat is conducted through a material. This one, it relates the heat conducting ability of a material to its heat storability. Basically, yung thermal conductivity, it tells us the rate of heat transfer only. Okay? Heat transfer lang siya kung gaano siya kagaling or ka-fast mag-heat transfer. On the other hand, yung thermal diffusivity natin, it tells us about the rate of heat transfer and also yung heat storability or the effect on the temperature change of the body due to conduction that is being experienced by the commodity. Okay? So skip ko na to. Basically, yung last row, similar din to doon sa sa specific heat capacity wherein yung temperature and moisture content based sa mga literature have shown that there is an effect or correlation between the temperature change and moisture change dito sa tatlong thermal properties natin. Okay? So ito na, papakita ko na yung mga methods of measurement of our specific heat capacity. For some, meron tayong may method na hindi lang specific heat yung kaya niyang i-measure. Na-measure din niya yung thermal conductivity and diffusivity. Okay, first is the guarded plate cylindrical or spherical cell method. We have the hot wire, the method of mixtures, the differential scanning, calorimetry. Okay, so for the first one, we have guarded plate method, or if you remember dun sa nung BS or MS, meron sa Fourier's law, 'di ba lagi may example doon na wall, 'di ba? Fourier's law, heat transfer Q is equal to Ka delta T, change in temperature over delta X. 'Di ba? So nagbabago lang yung X kung cylindrical or spherical, 'di ba? Yung R so guarded plate. So based yung principle na nitong nung method na to doon sa Fourier's law, knowing that because of steady state condition, di ba, we have constant Q. So ito yung setup kasi niya. So in here you can see that this technique involves a heat source and a heat sink principle. Okay? So in this case, ito yung heat source mo and yung heat sink mo is your ice bath. So magkakaroon kayo ng known temperature and then you have a metal cylinder right here. Tapos ito dito, nandyan yung specimen nyo. This time around, ang specimen is a potato. So with a known delta X, a known diameter for the area, diba? KA, yung A. So mako-compute nyo yung K dun sa equation. Diba? So you use the Fourier's equation for this one. Okay, that is called, so ito kasi, ito, front view yan eh. That is actually a cylindrical, so cylindrical, ito, cylindrical siya. Cylindrical cell method. Front view yung shot. Okay, so yeah, that's your guarded plate. By the way, this one, this is also called the steady state method. Okay, now, kung yun ay steady state, ito naman, yung opposite of steady, this one is the transient line heat source method or transient method. Ang tawag dito ay hot wire method. So, itong method na to, they are relatively quick, which gives them an advantage over steady state techniques. And this has been widely used in the determination of the thermal conductivity of most commodities. Okay, so, ayan, mga sensors kasi ito. Ayan, di ba? Kaya madali yung readings nila. Now, nakalagay dyan, no, yung sensors na nakita ko, it can actually measure yung thermal conductivity, thermal diffusivity, and even the specific heat. This one, yung transient method or hot wire method, they generally employ needle probes, may mga probes, or in this case, makikita nyo, may mga wires. May ipapalsak dun sa commodity. Ganon. Okay? Yung next naman ay method. By the way, ito ay nandun sa malaking table, dun sa module nyo, naka-tabular version siya dyan. So, yeah. Method of mixtures. Ito naman, I'm gonna show you a quick ba to? Na simulation. Okay? Method of mixtures or differential scanning calorimetry. Pinagsama ko to dyan sa table nyo kasi magkahiwalay sila. But basically, both methods use both use calorimetry. Diba nakalagay dun sa table. Sabi dun sa description, no, basahin ko lang dun sa table. For method of mixtures, yung specific heat natin is determined by heat exchange balance after the sample is dropped in a calorimeter and equilibrium temperature is achieved. Bale, ang mangyayari, meron kayong chamber, tapos what happens is you observe yung change in heat from a known sample. May makikita nyo doon sa video, which is water. Yung heat loss, so yung heat gained by the water is actually equal. In-equate niya, equal siya doon sa heat loss from the measured substance. Kung kanina, Fourier's law, yung theory, dito naman, ang theory nyo, ang working theory nyo is the first law of thermo. Diba? Conservation of energy principle. If you remember, it states that energy cannot be created nor destroyed, but it can change forms. Diba? Pwede siyang magbago ng form. So yung working equation natin, if you remember, sa first law of thermo, you have, diba, yung net energy transfer natin. Q in minus Q out. Yung Q in minus Q out natin, pwede siyang heat, pwedeng work, pwedeng mass transfer. That will be equal to the change in energy of the system. Yung change in energy, that could be internal energy, U, or pwedeng kinetic energy, pwedeng potential energy, etc. I'm telling you this kasi makikita niyo siya dun sa video na ipapakita ko. So, mamaya, ang makikita niyong video ay, it's a simulation since online na set up dito sa campus. So, may mga subscription kasi. Tapos ito is, may subscription yung university sa Lab Store. So, meron siyang, kung nagko-computer games kayo, parang computer gaming yung dating niya. It's a simulation, papakita sa inyo paano nag-work yung isang calorimeter. But specifically, itong available lang na video ay bomb calorimeter yung panakita, no? Pero basically, yung binanggit na method, yung principle ng method of mixtures, heat loss from the measured substance is equal to the heat gain of water. Ganun yung makikita nyo rito. Basically, yung DSC rin, yung Differential Scanning Calorimetry, ganun din yung principle niya. Heat flow rate to the sample is programmed to a specific environment and monitored versus time or temperature. So, ganun din. May graph din ng heat flow against temperature. Okay, so, play ko lang. Share ko lang yung audio. Medyo mabilis lang din to, no? Kasi
to help the engineer assess if gasoline is a good chemical for
ayun, disclaimer pala. Yung itatest niya dito is sa gasoline, okay? Isipin niyo na lang na pwede, palitan niyo na lang na yung gasoline. Pwede kasi yung energy content or calorific value ng ibang commodity.
storing energy, you should find out how much energy gasoline contains. How do you think we can determine how much energy is stored in a chemical compound? Yes, that is an excellent idea. The science of measuring the change in heat associated with a chemical reaction is called calorimetry. It just so happens that we have a state-of-the-art calorimeter right here in the lab. Go to the fume hood to check out the calorimeter. In this fume hood you can find all the equipment you need in order to determine the energy content of a sample of octane. Octane is a main component of gasoline. Touch the control panel to activate the calorimeter. Check out the items in the fume hood and raise your lap head when you are done. Are you done exploring? Great. Then let's carry on with this. In this experiment you will combust a sample of 1.0 gram of octane to determine its energy content. Before you handle chemicals like octane, remember to put on gloves. Find a glove box and click on it to wear gloves. Open the analytical balance and place the crucible inside. Press tear on the analytical balance. I have set the automatic pipette to pick up 1 gram of octane for you. Pick up add a pipette tip to the pipette. Use the pipette to transfer octane. Empty the pipette into the crucible. Discard the used pipette tip in the trash bin. Put the pipette back in the pipette holder. Now you should place the crucible in the holder in the oxygen vessel top. Create a connection between the liquid sample and the ignition wire by placing a small piece of cotton string on the ignition wire. Dispose of your gloves in the trash bin. Insert the top part of the oxygen vessel into the bottom part. Place the oxygen vessel in the oxygen vessel dock of the calorimeter. Push the insert button on the control panel of the calorimeter. I have teleported you inside the calorimeter to see what's going on. As you can see, the oxygen vessel is now placed securely inside. Push the oxygen fill button to pressurize the oxygen vessel with oxygen. Now the pressure of the chamber has reached the preset value of 25 bar. Press the water in button to fill the water bath. Now you must wait for the temperature to stabilize. Now the temperature of the water bath and the oxygen vessel have stabilized. Push the ignite button to start the combustion reaction. This sample is combusting inside the oxygen vessel. As the reaction occurs, the heat generated by combustion gradually heats up the oxygen vessel and the surrounding water. Now the combustion reaction is complete, but the oxygen vessel is still giving off heat to the surrounding water bath. Wait for the temperature to stabilize. An impressive piece of equipment, right? Now the temperature has stabilized. You can see the output from the calorimeter on the screen to your right. The graph shows the temperature of the water bath as a function of time. Click on the screen where the initial temperature is stable. Yes, you are right. Click on the screen where the final temperature is stable. Yes, spot on. The difference between the two is the change in temperature associated with the reaction. You can see the calculation of delta T on the right screen. The temperature change and the heat of reaction are not the same, but they are related by the simple formula which you see on the formula board, delta H equals C times delta T. Where delta H is the change in heat, C is the total heat capacity, and delta T is the change in temperature. The total heat capacity is the sum of the specific heat capacity of the calorimeter and the specific heat capacity of water times the mass of water in the water bath. You can see the formula on the formula board. The specific heat capacity of the calorimeter can be found experimentally, but luckily for you, this is a virtual lab, so I have already determined it for you. You can see the calculation on the formula board. Now we can calculate the heat of reaction, delta H. You can see the value on the formula board. The heat of reaction that you just measured is also called the enthalpy of reaction, and since the reaction is a combustion reaction, it is called the enthalpy of combustion. The unit of enthalpy is joules. What is joules a measure of? Excellent! Joules are a measure of energy. But how exactly is enthalpy related to energy? Click on the second tab of the formula board. The relationship between the enthalpy, H, and the internal energy, U, of a system is given by the equation H equals U plus P times V, where P is the pressure and V is the volume of the system. In the bomb calorimeter we were measuring the change in enthalpy, delta H. That changes the equation to delta H equals delta U plus delta P times V. Which part of the equation stays constant in this experiment? That's right. The bomb calorimeter has a fixed volume, so V doesn't change. Since the volume is constant, the equation can be written like this, delta H equals delta U plus V times delta P. Because we pressurized the vessel with oxygen before the reaction, the change in pressure is very small. What happens to the equation if the change in pressure is very small? It may help you to look at this image. That's right. When the change in pressure is very small, the entire term V times delta P approaches zero and becomes much smaller than delta U. So it's fair to make the assumption that the change in enthalpy equals the change in energy. With this assumption you have actually determined the internal energy of 1.0 grams of octane. This is also referred to as the specific energy of octane.
Ayun. So, basically, that's how a calorimeter works. Ang working equation niya will be yung energy balance ng first law of thermo, which is E in minus E out is equal to change in energy of a system. And yung nakita nyo, in-explain niya kanina, yung delta U na lang yung natira dun sa change in energy of the system. So, matinira na lang is yung Q minus W. Pero yun, hindi. Normally, actually, pagka ginagamit tong mga calorimeter, nandun na siya na magpa-pop na lang dun sa reading niya yung actual reading. Yung value ng parameter na dinedetermine mo. Okay, so yun yung calorimeter natin para ma-appreciate nyo yung mga methods natin na available. Now, ito naman yung modeling of the thermal processes in the post-harvest. Another way for us to determine the thermal properties is through models or empirical equations. The modeling of thermal processes in the post-harvest is based on the mathematical statement of the conservation laws. So it's a combination of the conservation of mass, momentum, and energy. It is a working derivation niya will be continuity equation and Reynolds average Navier-Stokes. Yun yung mga working equations na hindi natin ito i-discuss, no? Pero yun, mahabang derivation para makakuha ng mga working empirical models. Ayan. So, in our version, naka-table na siya. Okay? Pero yun, may reason behind that. At ang reason or principle behind that ay ito, continuity equation and Reynolds average Navier-Stokes. Ayan. So, due to the complexity and size scale of a fully loaded cold storage room and a reefer container, mathematical modeling of these systems is computationally difficult. To this end, the method of volume average is employed. So, tinutukoy dito ay yung averaging, depende kung ilang, parang partitioning, ayun. Partitioning of allotted space for a specific commodity. Generally, food materials are non-homogeneous.